To explore the primary dimensions and to consider what is fundamental beyond nothing, I first did an intermediate amount of internet research on the fundamental constants for the purposes of helping solidify in my mind what exactly was fundamental in the world of physics, assuming physics was the field to study to determine what is fundamental to reality. The fundamental constants aren't all of what is fundamental, but it is a good start. If this is the first video of mine on dimensionalism you are watching, I recommend that you start watching the dimensionalism playlist from the beginning, as important disclosures are given in the first video to be forthright about my genuity. Also, the rationale in the previous video is built upon here and in later parts, so continue viewing at your own discretion. But the TLDW is that I am not a physicist, nor a mathematician. I do believe, however, that I am a reasonable logician, is that the word? Logician? With years of critical thinking experience, and I am not afraid to be wrong whenever greater reasoning presents itself. So take what I say here with a skeptical grain of salt, and as always, think for yourself. So back to the fundamentals of physics. There has almost always been contention among physicists about what is or is not fundamental to reality, and I may very well add to that contention with what I will present today. But in order to even come close to building a cohesive, grand, unified theory of everything, having the fundamentals logically set in place is surely necessary. And it surprised me that more than one astrophysicist had a dismissive attitude towards spending too much time trying to get a clearer picture of the fundamentals. I mean, I won't call out any names because that could potentially embarrass them. But upon logical deduction, and after breaking down the fundamental constants into their primary dimensions, I came to the conclusion that there are 4 primary dimensions beyond the quantitative realm where 0 abides, and that is mass, electric current, length, and time. These dimensions cannot be broken down and made to appear as a sum of any of the other primary dimensions, hence their primacy. So why is there only 4 primary dimensions that comprise our reality? Some may ask, why isn't temperature or luminosity or the mole included in the primary dimensions? Because there are 7 base units in the SI system, and I'm glad you asked. The lumens dimensions are hertz times watts divided by steradian, and the hertz dimensions by itself is an amount, Q, which I designate as Q, over T, and watts, the watts dimensions are mass times length squared over time to the third. And steradians is just length squared over length squared, which reduces to Q. So the lumens dimensions, based off of the other dimensions that comprise it, are m times L2, L to the second, over T to the fourth. Now the mole can be reduced because it is quantity of matter, and the matter's dimensions are anything that has mass and volume. So anything that is measured with the mole is the amount of mass times volume. And temperature, the dimensions of temperature are kinetic energy divided by matter. The dimensions of energy are mass times length squared over T squared. And as we already showed up here, the dimensions of matter are mass times L to the third. So after reducing the math of the mass and the length squared on the top and the bottom, we just get with Q over L times T to the second. Now, going back to the matter, can matter be massless? No, because it is literally in the definition of matter, which is anything that has mass and takes up volume. But this would make things like photons and gluons not matter per se, but so some bosonic particles aren't necessarily a part of the umbrella term of matter. And temperature itself can be broken down as well. Temperature is defined as the average kinetic energy of the particles of a substance. So I subsequently looked up what exactly a particle was by definition to be sure that photons and gluons can even be considered particles, and it said a minute portion of matter. So maybe we should think about redefining to better clarify that the massless particles of photons and gluons are still bosonic particles. It's just a thought. And in the final dimensions of temperature, like being without mass, can help explain that photons, things without mass in the electric field, can exhibit temperature, express energy, create forces, all while being statically massless. And this clarification of temperature's primary dimensions may also help explain why the cosmic microwave background is not at an absolute zero temperature, but is a little over 2 Kelvin. I think it's 2.7 Kelvin. It is the cosmic microwave background temperature is that way because it is the combined temperature of the electromagnetic waves being carried by photons permeating through space. So that should help clarify why there are only 4 primary dimensions. But this only shows what primary dimensions exist in reality. It doesn't show how many of each dimension there are. So to determine how many of each dimension there are, I did something unorthodox to the scientific community. But I used Wikipedia to see what the max iteration of each of these primary dimensions are. So I did this by going to the International System of Units Wikipedia page and press Ctrl F to search M for meters for length, S for seconds for time, kg for kilograms for mass, and A for ampere for electric current with numbers next to them to find out if they were ever squared, cubed, etc. And after using that method, I was able to conclude that there are 3 length dimensions, kind of obvious, 4 time dimensions, 1 mass dimension, and 2 electric current dimensions. And these are all, of course, in addition to the 0th null dimension of quantitative measurements. So this implies that we live in a 10-dimensional plane of existence. So with this information, we can name the fundamental fields according to the dimensions that comprise them. The length field is obviously called space. The electric field is, again, obviously called the electromagnetic field. The mass field is what has been observed to be the Higgs field. And the time field, I've chosen to name the causality field because I believe it fits the most appropriately. So the dimensions, the 0th dimension is quantitative measurements. The dimension with 1 iteration is mass. The dimension with 2 iterations is electric current. The dimension with 3 iterations is length. And the dimension with 4 iterations is time. And together, they spell DQ melt. I thought that was pretty interesting. It made me a little too happy. It made me look up if there were any DQ melts on in the Dairy Queen menu. And they did sell something like a Hot Pocket melt back in 2015, but they don't have any melts as of me doing this video in 2020. Although, either way, if you tried buying their ice cream and you don't quickly put it into your belly, their ice cream will surely melt. Hashtag not a sponsor. So anyways, back to the breaking down of the fundamental constants into their primary dimensions. This part is kind of boring in the paper and it is kind of unnecessary to go into detail for this video, so I will just do a condensed version of what I did here. So I'll put the link to the final draft of Dimensionalism 1.0 in the last video's description whenever I am done with it. Alright, the speed of light's dimensions obviously is meters per second, so it'll be L over T, length over time. The elementary charge dimensions is the ampere times time, so E times T. The electric constants dimensions are farads per meter, and Farads dimensions are seconds to the 4th, amps to the 2nd, kilograms times meter squared, which reduces to this. The meter is obviously L, and then you just combine those two things together in the original equation to get, that is what the electric constant dimensions are. You pretty much do the same thing for the magnetic constant, newtons per ampere. The newtons is mass times length over time squared. The ampere is E squared. So the magnetic constant, mass times the length over E squared times T squared. The Planck constant is joules per second, and I just skipped the math on that because I was running out of room on the board. Mass times length squared over T to the third. And this is where I found some interesting findings. The fine structure constant. Because the fine structure constant is claimed to be dimensionless, so I just put a Q next to it. But something you can do on your own if you want to exercise a little bit is prove mathematically that is actually equal to Q. And another challenge, if you're up for it, is reverse calculate the speed of light's dimensions by taking this accepted equation for the speed of light and making sure that it actually is equal to length over time. Now there are 3 more constants with weird results that I want to show you, and they have a couple of things in common. They all use temperature to define their dimensions, and famous scientist Ludwig Boltzmann had his hand in all of them. I'll skip the math on this part and just share the verbal results. The molar gas constant's dimensions are actually dimensionless. In hindsight, this finding is kind of obvious. The molar gas constant is also known as the Boltzmann constant, expressed in energy per temperature increment per mole. And knowing what we dimensionally know about temperature, essentially being energy per mole, essentially this is saying the Boltzmann constant expressed in energy per mole. And if it is energy per energy, that would equal 1. And if it is over mole per mole, that would also be equal 1, which is equal to Q. And secondly, the Boltzmann constant's dimensions ended up being equal to the mole's dimensions, for the same reason being energy per mole, which just ends up simplifying to just the mole. And this may seem randomly off topic, but entropy also shares the dimension of energy divided by temperature. So here's a thought. Perhaps the concept of entropy is something akin to matter radiation or particle field radiation. Back on the topic. Lastly, the Stefan-Boltzmann constant has so many issues with it. None of the equations add up to the same dimensional result. All of the dimensional results give ridiculous answers with more than 3 length dimensions. The most ridiculous one being the last equation that I did in the paper, giving the result of 7 mass dimensions, 11 time dimensions, and a whole whopping 20 length dimensions. 20 length dimensions. So this last constant in particular needs to be carefully revisited by physicists to reconsider the constancy of this constant, since it takes 2 secondary dimensions, temperature and amount of matter, and treats them as primary. And well, do I even need to bring up the 20 length dimensions again? This isn't to say that secondary dimensions can never be squared or become products of each other in any way, but that any tertiary dimension that is used to express phenomenon that secondary dimensions cannot reach should rather be considered an imaginary dimension. Like every time we imagine 4-dimensional space objects, those should be considered imaginary dimensions, and anything that has additional of any of the other types of dimensions should also be considered an imaginary dimension. And any tertiary dimension that could otherwise be expressed as a secondary dimension should be renamed and used as a secondary dimension. Well, that's it for this episode. If you like critically thinking over a larger variety of topics and like the level of thinking that went into this video, please do us a giddy and click on those like and subscribe buttons. Please. Next time I'm going to be counting the number of secondary dimensions and start exploring the limits of what we can directly measure in our reality. And until next time, kumbaya, mother duckers.